Hello, everybody. My name is Duc-Phong. I'm working as a Canadian Institute for Cybersecurity. Today, I'm talking about synthetic data, how to generate and evaluate the synthetic data. This talk consists of the three main sections: problem statement, the methods for synthesizing the data, in which we discuss about the challenges, the process, and the approaches in synthetic data generation. And the last session, we talk about evaluations of synthetic data, where we have to evaluate the two property, utility, and privacy. Nowadays, with the more and more connected device and the Internet of Things, data is every corner, and data is getting more important in every field of our life. For example, company can use the data to analyze and to make a better business position. Different organizations can share the data to perform better research. But actually, we have one problem with data privacy. Sorry, as a data owner, you share the data to data collector, and you want the data collector to store the data properly. You don't want the data collector to share to use the personal data for different purpose from the original purpose. Right? Sorry. One solution for that is that we can use the synthetic data that is generated from the origin of the geo data. We are going to the generation method. The challenges in synthetic data generation includes providing the data utility and providing the data privacy. The data utility means that the synthetic data has to provide the same statistical property, for example, distribution, correlation, and structure of data. And it also provides the same result for all queries to the synthetic data as the queries you send, the same queries you send to the original data. Regarding the data privacy, we have to guarantee that the synthetic data to fulfill with the requirement from the regulatory standards, for example, GDPR requirement. And we also have to provide the differential privacy. This is a theoretical privacy requirement. To generate the data, this picture shows the process of the synthetic data generation. So we have a synthesizer. It takes an input a geo data set and produce a model, and after that generate a synthetic data. This synthetic data will be evaluated based on two property, utility and privacy. The result of evaluation will be feedback to the synthesizer and to improve the synthetic data. Ideally, in this picture you see, ideally we need we want to have a synthetic data with a maximum of utility and maximum privacy, right? But actually, it's impossible in practical. When the utility go into maximum, the privacy will go to the minimum, and another way around. So it's a trade-off the process. We need to find some point in which we have the reasonable utility and privacy. Synthetic data generation actually have been researched for nearly three decades. The first work is in 1993 in the context of the statistical disclosure limitation. And basically, there's three categories of the synthetic data: fully, partially, and hybrid synthetic data. So far, there are three main approaches: imputation-based methods, full joint probability distribution methods, and using deep learning methods. For imputation methods, it's all initially introduced in statistics as a mean to fill in the missing data. And then in the 1993, it was proposed as a mean to generate fully synthetic data. For this one, this method we check for one data set, we have two types of feature. We have identifying and sensitive feature. For example, in the census, in census data set, the birth, marital status, and gender are identifying feature, and income is a sensitive feature. So this method we check the sensitive data as missing value, and then it trained with the identifying feature and a part of the sensitive value, and get a model, and then it's randomly release sample imputed value. So, it samples this method. We sample M data set from imputed population. This the probable of the maximal randomness in the data set due to sampling from population and sampling from imputation value. For full probability Joyce distribution methods, we have one problem with imputation-based methods. This method may not preserve the correlation between attributes because it studies the marginal distribution of the data set. So the full probability Joyce distribution methods can address this matter. Because this one studies not only the marginal distribution, it also studies the joint distribution and correlations between variables in the real data set. One tool can realize this kind of method is a Bayesian network. You can see in this picture, let's say you have a data set with the attribute as education, work class, title, and finally income. So this network shows the dependency between the, for example, income from class, work class, and title is the direct dependence. And we also have indirect dependence from S to income and education to income. The last class of methods I am talking about here is using deep learning. Here, in particularly, we use generative adversarial network. Actually, GAN is a popular class of the deep neural network, and in this method, we use two networks. We call the generator and discriminator. So, while the generator try to generate synthetic data, it's as similar the geo data as possible. So, and then the discriminator try to discriminate the geo data from the synthetic data. The feedback from the discriminator will return to the generator, so that generator can improve the quality of the synthetic data. Actually, this network often is a game in the zero-sum game. So now we go into the evaluation of the synthetic data. To evaluate the two properties, utility and privacy of synthetic data, we have two approaches. Basically, it's a statistical measurement and the AI-based measurement. For measuring the utility, we can measure the univariate distribution, joint distribution, correlation between variables in the data set, and machine learning score similarities. For example, univariate distribution, we can measure and compare the basic statistics such as mean, median, standard deviation, or histogram, etc. In the pictures, you can see the histograms comparison between the two data sets, geo data and synthetic data. So it should provide the similar statistical you see in the histograms between the synthetic data and geo data. For machine learning score similarities, we can use the score like such as accuracy F1 score for classification problem, and we can use the mean relative error for the regression problem. For privacy, we can assess, we have to assess two things. It's a differential privacy, is a theoretical privacy requirement, and the requirement from the practical privacy act. For example, the requirement from the GDPR. So for differential privacy, usually it can be realized by using some mechanism such as Laplace, Gaussian, exponential, or global sensitivity mechanism. To measure the privacy from the practical privacy act, we can implement and measure the hitting rate, record linkage, and the distance to the closest records. Yes, that's all from my presentation today. Thank you for your attention.